So in example number 1 here, we've been given the scores for a rugby team over a series of matches. We can see that he scored 13 points in the first match, 7 in the second, none in the third, and so on for 7 matches here. So we've been asked in part A to calculate the mean and also the standard deviation. So part A here, to calculate the mean, would involve us adding the points together and then dividing by the number of matches that we had in this case. So the mean, as we've seen before, is represented by x bar, and what we're looking to do is find the total of all the values in the data set. So that means to add them all up, and the Greek letter sigma, which we've seen, sigma x, means to add up all the x values, and then we're going to divide by the number of values we have, which is n. Now, in this example, when we add these together, we get 49, and it really is a good idea not to write out the addition. You don't need to write 13 plus 7 plus 0, etc., but get the total there so that you know what sigma x is equal to, because you'll need it later on. And n is 7, and when we do this division, we get 7. Now the mean is measured in the same units as the original values, so it's points in this case. So 7 points. And that means that on average the team scored 7 points per game. Make sure that you notice that even if one of the values is 0, it still counts to the total number of data items, so that's why we divided by 7. We're including the 0 there. Now on to part, not quite onto part B, standard deviation now for us. I'm going to use the letter S for standard deviation, and we want to use the formula that's given to you in your formula sheet. Now it's quite complicated, so it's best to build it up like this. The first thing on the numerator is sigma x squared, and from that we're going to subtract this thing. It's a fraction itself, and it's sigma x in brackets all squared. Now they're very different, these two. With sigma x all squared, basically all we need is sigma x, which is the value we had up here, anyway, 49, and we're going to square it. So 1 squaring goes on here, and then the answer to that gets divided by n, the number of items. This sigma x squared is different. There's going to be as many squarings as there are data items in the set. I'll show you how to calculate that in a minute. So then the next part of the formula is divided by n minus 1. The whole thing, and you've got to be clear that it is the whole thing, is wrapped up in a great big square root sign, or radical it's called. So there's the formula, and my advice here is to build up the formula, get the components that you need, so we can work out sigma x squared over here. And the way to do that is to take each data item in turn, square it, and add it to the squares of all the others. So although you don't actually have to write this as part of your working, I'm going to put it in here. In fact, I'll just put it at the side here to show you what we're doing. So we're squaring the first data item, then adding on the square of the second data item, and then the third data item. Now it happens to be 0, so it makes no difference whether you square that or not. Adding on the square of the next one, adding on the square of the 7, adding on 8 squared, and finally adding on 5 squared. So there's a lot of squaring and adding going on here. Square and add, square and add, square and add. And that, in this case, gives us sigma x squared, which is 437. I'll just say that again. To calculate sigma x squared, which is this bit, is going to go into our formula. We take each data item, square it and add it to the squares of all the others. So squaring and adding till all the data items are dealt with. Now this part of the formula, sigma x in brackets squared, all over n, is a little bit easier to get because we've already got sigma x. We know what adding all the x values up gets us, adding all the data items up. Adding all these up gave us this thing, this 49 that we'd seen earlier, and then we need to divide by the number of data items. So it's 49 squared, remember this squaring here, divided by 7. In this case giving us 343. And these two values will always be relatively close together. Not always significantly, but generally relatively close together. If you get something that's 100 times bigger, then you've probably forgotten to do some part of the calculation. So now that we've got sigma x squared, and we've also worked out sigma x all squared over n, we've got these two values, we can go back to our formula and substitute them in. Sigma x squared, that's our 437, so that's going to go in in place of this on the numerator, and then from that we're going to subtract all of this thing, which was all of this thing, which is 343, and the whole thing divided by n minus 1, which in this case it was 7 data items, so we're dividing by 6, and all of that still under the root sign. Now the last step is really just to simplify this, and you can do that in one go in your calculator. Just make sure that the last thing you do is the square root. So key in the subtraction, divide by 6, work out what that is, and the root sign over the whole thing will give you something like 3.95811 and some stuff, which we'll need to round. Very often needing to round here because of the root sign. So let's go for 3.96, and this is measured in the same units as before, so 3.96 points, and that I've rounded to 3 significant figures. So the standard deviation here is round about 4 points, and that basically tells you how spread out these values, each one of these values are from the average, from the mean. So the mean was 7, and what we can expect is that these different scores on average will be about 4 points away from this mean of 7. Now when it comes to standard deviation, the working is important, so you don't want to miss anything out. The bit that I put in pink here you don't need to write, you just key that into your calculator, but everything else I've written here needs to be down. So the formula, and then work out the separate parts, and then substitute them in, simplify it, and then any rounding that's required. And then we can have a look at part B. We're told that the following season the team appoints a new coach and a similar series of matches produces a mean score of 17 points, standard deviation of 8 points. We've been asked to make 2 valid comments, and usually this question is worth 2 marks, so you must write 2 comments about the performance of the team under the new coach. So what we can say is that on average, since the mean is a type of average, we used to be scoring 7 points per match, and now we're scoring 17 points per match. So we can certainly say that on average the number of points scored per match under the new coach has increased, and that would be the sort of sentence you would want to write. So I'll just squeeze it in here. Part B, start your sentence with on average, and then we can say the number of points and this is because we're comparing the means. So the number of points scored per match increased under the new coach. Now we need to sort of justify why we can make this statement, and the reason for that is because we are comparing those means together, and we realise that 17 is a much bigger value, well certainly is a greater value than 7, so we can just say 17 is greater than 7, and that's our justification for being able to say this. So that's us compared the means together, but we also need to consider the standard deviation. Remember, this new coach got a standard deviation of 8 points, whereas we'd calculated that under the old coach we had a standard deviation of around about 4 points. What that means is that under the new coach the number of points scored is less consistent. At least when you had the old coach, you were scoring on average 7 points, and then every match you could expect to be either 4 above or 4 below 7. But now under this new coach, although we're scoring 17 points on average, it is possible that you'll be 8 points above that or 8 points below that. So the number of points scored per game under the new coach is varying a lot more than it did under the old coach. Still probably a good thing for this team because they're scoring more points, but we need to make a statement, and our second statement, I'll just change colour for that one. We would say something like the number of points scored per match under the new coach is less consistent, which is not a bad thing. As I said, it just means you don't really know what you're going to get if you go and watch this team play. And why are we actually making that statement? How can we make that statement? Well, that's because the standard deviation is now much greater. So if we have a look at the standard deviation, it's now 8. So this is because 8 is greater than 3.96. And just a final thing here, what is important, I think if you start off your sentence with on average, those are the key words to sort of get in there so that triggers your communication, and then also using the words consistent, either less consistent or maybe more consistent depending on whether the standard deviation has increased or has dropped, and that will guarantee that you get full marks on this question.